Andariki namaskaramulu. Today we are going to start a new topic, Vedic mathematics by Gautham Mukherjee ji. He is known to all of us. He doesn't need a special introduction. Let us start the session with Chala Chitti Babu garu reciting Vande Mataram, please.
Vande Mataram, Vande Mataram, Sujalam Sufalam, Malaya Sitalam, Sasya Syamalam Mataram, Vande Mataram. Subrajyosna pulakitayamini pullakusumita drumadala shobhini suhasini sumadhurabhashini sukhadam varadam mataram vande mataram. Vande Mataram. Namaskar.
Vande Mataram. Let us request Venkateswarlu garu to chant Pradhana, please.
Namaskaram andi. Sarvebhyo namaskara. 1 minute silent meditation చేద్దాము. తర్వాత 3 times ఓంకారము. Om Gananam Tva Ganapatigam Havamahe Kavim Kavinam Upamasravastamam Jyeshtarajyam Brahmanam Brahmanaspata Anashrunvannoti Bissida Sadhanam. Om Shri Mahaganadhipataye Namaha. Om Prano Devi Saraswati Vajebhirvajanivati Dhinamavavitrjavatu. Om Shri Mahasaraswatyai Namaha. Gurureva Gatir Gurumeva Bhaje Gurunaiva Sahasmi Namo Gurave Na Guroh Paramam Sisurasmi Guroh Matirasti Gurau Mama Pahi Guru. Jnananandamayan Devan Nirmalaspatikakrutim Adharam Sarva Vidyanam Hayagrivam Upasmahe. Shruti Smriti Purananam Alayam Karunalayam Namami Bhagavat Pada Sankaram Loka Sankaram. शङ्करं शङ्कराचार्यं केशवं बादरायणं सूत्रभाष्यकृतौ वन्दे भगवन्तौ पुनः पुनः। ईश्वरो गुरुरात्मेति मूर्तिभेदविभागिने व्योमवद्व्याप्तदेहाय दक्षिणामूर्तये नमः। असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतंगमय। ओम शांति शांति शांतिः। मातृदेवो भव पितृदेवो भव आचार्यदेवो भव अतिथिदेवो भव। ओम सहना भवतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै। ओम शांति शांति शांतिः। हरिः ओम श्री गुरुभ्यो नमः। हरिः ओम।
ధన్యవాదములండి వెంకటేశ్వర్లు గారు, చాలా బాగా చేశారు. Now I'll briefly introduce Gautham Mukherjee garu. He is well known to all of us, but it is my pleasure to introduce him briefly. He is MSc in Physics, Burdwan University, West Bengal, 1977. PhD in Physics from Indian Institute of Technology, IIT Kanpur, in 1986. I joined National Informatics Center, NIC, same as our Prabhuji, in 1990, and retired from NIC in 2016. The complete tenure he has in NIC itself, from the post of a senior technical director. And although interested and tried to follow Sanatana Dharma all throughout, interested in Vedic mathematics, that's why he is now teaching Vedic mathematics. So without going further, I request Gautham ji to start the session, please.
सर्वेभ्यो नमो नमो, सभी को नमस्कार. I will start my presentation and there itself. Yeah, screen. Now, is the screen coming?
It is coming.
Yes. Yeah.
But this bar is also coming, no?
Nothing. It's okay.
Oh, achha. Okay, okay. It is coming on my screen. Achha. So you can see the screen. So this is the introduction to Vedic mathematics, but the another level will be the second course and so on. My numbers are there here. Now, mathematics started with counting. To keep track of certain items, they used to put a dash on the ground with a stick and so on. So that is the primary number system to any anybody with a little amount of wheat, that okay, something we have to map the counting with that number of sticks with the number of items. Now, to ease the counting, they used to put after 5, they used to put a horizontal line. So these blocks of 5 makes it counting easy. Now, Babylonian has various symbols, 10, 100, etc., but didn't have the adequate number of symbols. So it cannot be this could not give rise to any proper number system. Now, Roman's number system, that is actually still in use in various ways. They are using, as you know, I, V, X, L, C, D, M, all these symbols. And they are some certain values, those are the values, and they are additive in nature. However, if the lower value is on the left of a higher value, this becomes a subtraction. We know all these things. VI is 6, whether IV is 4, and so on. Now, these are still used as ordinal numbers. The cardinal and ordinal numbers are the numbers normally we use, and this they are 1, 2, 3, 4, 5, as you know, and we count, we add, subtract, all these things, mathematical functions. Whereas the ordinal numbers, they are first, second, third, fourth, these kind of things are used. Same use of the same numbers, but in a different way. So we do it indicates some position, so first, second, and so on. So normally it is TH, but as you know, it is first, second, third are used differently. Now, mathematical calculation can be done only on cardinal numbers, whereas ordinal numbers, as we know that we do not put any TH or something like that, but still we know that P in Aadhaar there. Their multiplication, division, I mean, they're nothing to do with counting. This is just a arbitrary number. So those are ordinal numbers. Now, positional number system of India. Various countries have different various kinds of number system. But finally, what the number system got settled in with the positional number system in India. So it was known for a very long time. It is still exactly not known that how when it was discovered. But Aryabhatta in recent within 2000s in the year 400 AD, through Aryabhatta it started spreading throughout the world, first to Arabia and then to Europe. And by 8th century, this positional number system became the most dominant number system, and it superseded all other number systems like Babylonian. Roman was not good for counting, so they realized it, and then that gave way for the positional number system of India. And throughout the world, it has spread, but it is wrongly said about, it is named as Arabic number system, because Europeans knew it through Arabs only. Now, in this positional number system, we know already that symbols are 1 to 9 ordinarily, and then there is a place value within that place if there is no number to denote it. So then the heavy dot or a circle used to be put, and that is called the discovery of zero. But there is normally people say that what is the contribution of India in number system? Normally people they discover zero or zero. So it is not true. Zero is a corollary. Positional number system itself is the main contribution of India, which otherwise no mathematical or any scientific progress could have been possible. Thus, number symbol. This is very interesting. That number of symbols is equal to the base. That is the condition to get a proper number system. The number of symbols should be equal to the number in the base value. Now we come to this base and what is so on. Now the 0, we told the 0 is there, but 0 can be used as calculation that came slightly later. So in 628, Brahmagupta wrote a book called Brahmasutra Siddhanta. Sorry, Brahmasputra Siddhanta. And then this gives a arithmetic involving 0 and negative numbers. So it is like that we know all these things. These principles were discovered that time, that any number subtracted from same number gives 0. 0 added or subtracted to any number results in the same number. Any number multiplied with or divided from 0 produce 0. Square or square root is 0 is 0. However, division by 0 was not handled that time. Later on also in AD 830, Mahavira wrote this Ganita Sarasamhita. There too, this 0 handling, dividing by 0 was not handled. And even in AD 1100, Bhaskar wrongly stated that anything divided by 0 gets infinity. So he understood that something to do it very large, but as you know, the dividing by 0 is called indefinite, today's modern mathematical terms. Only that something divided by a small number, when that small number tends to 0, the result tends to infinity. That is the concept of using the concept of limit. This one reads it before they are reading calculus. One gets these ideas. So crudely, some people may think that it is dividing by 0 is infinity. It's not exactly true mathematically. Now, base and concept of base or the place value in the place value system. The position of place value system will be associated with the base. In India, in the worldwide number system, the base is 10. So 10 fingers might have give that idea to use 10 as a base. Now, so obviously it's called decimal. Is that there is a particular name, like octo, hepto, hexa, and so on. So decimal is the number system. So various powers of tens are used, as we know. In 10 hundreds, powers of tens are 0, 1, 2, 3, etc. In computer, however, where there can be only two kinds of states, whether the current and voltage is flowing or current and voltage is not there, either 0 or 1, or a switch is off denoted by 0, or the switch is on. So that switch can be electronic switch, it can be crude switch, visible switch, or an electronic circuit switch. So these can be only, there's two states, either off or on. Those are denoted by 0 and 1. And therefore, it gives a binary system because the number of symbols are only 2. So base also is 2. So that is called binary number system. When the binary is grouped into 3, it's called octal. There are some computers which used to handle octal numbers, and the base is 8. The digits used are 0 to 7. There are 8 numbers again, same as base. Again, nowadays it is used most commonly in computer. The binary is grouped into 4, and this is called hexadecimal, or base is 16. Digits are 0 to 9, all the symbols of the decimal. And then, since there is no more number systems are there, some alphabets are also used, A, B, C, D, E, F. These are also used as numerical digits, not as characters. And not as characters, not as text. And there is the value of 10 to 15. A is 10, B is 11, C is 12, and so on, and F is 15. So that we can, those who are interested can delve into this particular. Now, concept of place value and phase value. In place value system, the value associated with each placeholder, like unit, tens, and so on, it is called place value. And digit that occupies that placeholder is called the phase value. In the decimal system, as we are told to repeat, the place values are from right to left are unit, 10 to the power 0, 10, 10 to the power 1, the 100, 10 square, etc. And the any number that expressed as any number is expressed as a sum of place value multiplied by face value. For example, this 756 is 7 into 100 plus 5 into 10 plus 6, where 7, 5, and 6 are face values, and these are 1, 10, 100, these are place values. Now, negative place value, it is actually it is in fraction. You know, these fractions are expressed in decimal notation, like 0.34. It is actually 34 by 100 or 17 by 50. But when it is written as this 0.34 notation, and there you know that this place value of those 3 and 4 are in negative, 10 to the power minus 1, 10 to the power minus 2, and so on. Whereas not in common mathematics, modern mathematics is used normally. It is in basic mathematics we shall use it. It is called vinculum or negative face values. Negative face values. We'll come to that later. Now, numerical symbols world, numerical symbols in the world with hex codes, hexadecimal codes. So this numerical symbols, we are using in English 0 and 1 to 9. There are various countries, including India, there are various form of these things, and their hexadecimal code. Those are if you understand this hexadecimal code, Unicode can use these things more efficiently. And the English alphabet, the ASCII value most simple, this from 30 to 39, decimal 48 to 57. These are ASCII tables are there. A, B, C, D, everything are having some ASCII code. Because of ASCII code, they are getting displayed. You know that in the background, in the computer background, everything, whatever you write, those will have some ASCII code or something like that. So this 1 to 9, 0 to 9 symbols are with 30 to 39 on the ASCII codes. Now, this numerical, these are also having Unicodes, the coding of the Indian and other countries' symbols. But interestingly, although other alphabets or other things are not accepted as numbers, but these numbers, I have seen that this calculation can be done using the MS Excel sheet. Those are recognized as numbers. Numbers in Chinese and few countries, these will have place value. They do not use the place value system. That's what they use it as a text, just for representing the number, but calculation using a package like Excel, MS Excel, or any other package is not possible. A symbol displayed in this can be, one can try. In MS Word, it works actually. You write the hex code and followed by all text. So it will be displaying that number. And these are numbers are there. We know all that things. Hindi, Bengali, Punjabi, Gujarati, Odia, Tamil, Telugu. So this Telugu, you recognize that these numbers. Those of you are Bengali, there are participants of particular languages. They can see their own language, and these can be displayed and then can be used in Excel also, and can be calculated fully in that particular language. No problem. And their hex code is, for example, what is the hex code of, say, Telugu? This is called, 0, 1, 2, 3. So this is 3, looks like same. Say 4, 5. Suppose what to display this 5. What you have to do? 0C6B. We write 0C6B MS Word, and immediately followed by that we press the Alt key and then X, Alt X, so that this symbol will be displayed. Or you can set, when you set your language to Telugu, even the 1, 2, 3, 4 keys also will display those numbers. No problem. That particular key, there is a way to insert a language and for use, and you can use fully all Telugu and so on. So they can be in mobile, of course. These facilities are automatically there; it is already incorporated. So there is a Unicode corresponding to this, so that with the help of the Unicode, the computer uses those symbols. That's what. It displays like no problem. There are various ways to display. Now, there are other countries have various other symbols. English, which is most common. So Arabic, Thai, Lao, Tibetan, Myanmar, Ethiopia. So there are various symbols they use. Interestingly, zero also always looks like either it's a heavy dot here or it is all circle. Zero is the same in every thing I've seen. There are similarities in Indian, but there is some differences with the other countries' symbols. This is about the symbols made by this. Now, what is basic mathematics? We come to now actual topic, basic mathematics. It is actually intuitional use of 16 basic sutras or formulas. And there are 32 sub-sutras. Later only 13 are used. And these are some Atharva Veda Kalpa. Actually, there is a basic mathematics book they wrote where it is available. So it is some Kalpa in Atharva Veda. And basic mathematics is a collection of various alternative methods in solving some mathematical problem. So when you learn different alternative methods, you get a better control on the number system. That is what is required. And by intuitional, immediately by looking at some numbers, one can solve it. There are practices for that. One has to go deeply into that, deep in practice also. Then one can solve it very easily. Now, Vedic mathematics aims at developing mathematical intuition and choosing the best method. What is the best method? One can choose it. Sorry, acha, okay. No, there is no problem. Only you can see, do not see my image properly as power has gone. Or we can see, please. No problem. Okay.
We are able to see you. Go ahead.
Now, Vedic mathematics aims at developing mathematical intuition in choosing the best methods in case-to-case basis, rather than mechanically adhering to only one or few methods. From our childhood, we learned particular method of addition, subtraction, division, multiplication, and so on. But there can be alternative methods. Sometimes we learn in certain cases using some algebraic formula. Say we have to multiply, say 777 by 775. We do 776 plus 1 and minus 1. There are various cases we use now. So this is actually parallelly, it can do mental development also in parallel to that is being claimed. Like say Shakuntala Devi, she is a prodigy, of course, but we never know that by which method she gained that, she obtained that particular power. Anyway, this Vedic mathematics of Bharati Krishna Tirthaji, which basically I followed, and you can also purchase it. It is very cheap one. Even good hardbound is also 225 or so. In Amazon, you can order it. Later on, I may share the link also if you do not get. This is a good book actually. Now, these things are from that book only. There's a 16 sutras are listed here. Ekadhikano purveno nikhilam navatas charanamang dasataha urdhva We'll all some of them will learn, and not all. In this introduction to mathematics, we learn to some of them, and 13 sub-sutras. Some 13 sub-sutras are also listed here. And there is also this, I'll share this one. There is a English meaning of all these things. Later on you can see. Ekadikana Purva means one more than the previous number. And Nikhilam Navatas Charamang Dasata means all from 9, and the ultimate or the rightmost digit is have to be subtracted from 10. This basically from means subtracted from 9. This may also mean subtracted from 10. The ultimate one. Urdu Tijagabham with upper and slant. Upper straight and straight also is used in some cases, but mostly it is upper Tijagabham slant. Paravarta Jojayat, transport and apply. Transpose and apply. Shunnam Shambho Samuchaya. A common factor is the same, which is 0. Like that way, there is actually, there are various these meanings of all these Sanskrit to English translation are there, all the sutras. Chalana Kalanabhyam. Colon means actually differentiation. This colon is used for calculus. Jabadanam and so on. There are so many other things. This is just for general reading. You can go through. They also text which is actually gave all these things. Now, scope of basic mathematics. Arithmetic computation can be done, then multiplication, division, recurring decimals, divisibility. We learn divisibility in school, say divisibility by numbers like 3, 9, 11, and any, say 2, 4, 5, 6, and 8, etc. But we skip 7 somehow. There it is written that 7 may be complicated, and 7, 13, 17, all these things may be complicated. But actually, it's not true. We'll see when you see that it is a more generalized cases of division by divisibility by 3, 9, and 11. 3, 9, and 11 are special cases of a method, and 7, 13, etc. can be used by that. We'll learn that. And then HCF, all these things can be the square root. This will be in the second level course. Square and square root. Maybe it will be third level cube root. We see equations, factorization, differentiation, integration, and so on. Now we come to the arithmetical computation part. Disturbance can here. 1 minute. So the addition, subtraction, multiplication, division, we learn since our school days, but actually they have some algebraic background. We do not always learn that algebraic background. However, when the algebraic background, the algebra is changed, the background algebra is changed, the procedure will be changed automatically. This Vedic mathematics actually do not. It's not like that you have some algebra and use the conventional ways, our own normal, the one way we learn, use that same way to handle that algebra. It's not that. It is a procedural change. So Vedic mathematics is a, this you can say, mental setup that we are changing the procedure itself. In this session, we shall learn some such alternative procedures. That is it. Procedural change is most important. In Vedic mathematics, both positive and negative phase values are used. I already told that for digits more than 5, we have to handle, it is better to handle digits less than 5 than more than 5. So when digits is more than 5, the negative phase value is used, which is called vinculam. We write, for example, 48, we can write as 5 and 2 is a bar. This is called vinculam symbol. And obviously, it is easier to use 2 than 8. So you'll see that we'll handle it. Concept of vinculam again. Now, it is actually negative phase value number. Now, there is a symbol this is Unicode 305. It gives a bar, but I've seen that it's not very convenient to use. So therefore, you will use some graphical symbol like this. So now here general discussion is there on what is the how to use the vinculum and its conversion. See, 6, the number is the most simplest number, the first single digit number. We can write it 1 and 4 with the vinculum. Like 8 will be 1 and 2 with vinculum. 97 is 100 minus 3, so it is called 1, 0, and then 3 above top. So this well-known number is there is 143 and negative 143 on vinculum. Basically, it means that 143000, and these are actually 143 negative. So, as you know that 3 is negative, minus 3 with unit, minus 4 in 10th digit, minus 4, minus 1 in 100 digits will give us to minus 143 totally, in total. So this will actually subtracted. What we do when we subtract this way, this will known in conventional mathematics. We subtract these things. Last one is from, you can note down, we never noted down properly. But maybe that I'm not telling. Last one is always subtracted from 10, and others are subtracted from 9. It automatically do it. But actually, when we in mathematics, we systematically write this number, Nikilam Navatas Charmadasta. We in that way we do not subtract exactly, but we simply follow the formula. This amounts to our subtraction. We know already, but in this particular sentence, not as this particular sentence. So last one, you will always see when you subtract something from 0, 0, 0, 0, and so on, something. We always subtract the last one from 10, and others we automatically we subtract from 9, and then finally we arrive at the result. So this way, this in the background it happens, but we write we follow that and we while converting from vinculum to non-vinculum, we reduce this ultimate digit, which is the starting of the vinculum, we reduce by 1, whereas here, for example, we add one number. This is ekonunna purnamana or ekadikonu purnamana, as it is the conversion requires. 289 is 300 minus 11, so it becomes 2 becomes 3, and these are Nikhilam Navatas Chalmadasata. So it is 8 and 9. Okay. This 9 we subtracted from 9 we subtracted from 10. It became 1, 11, this 1 vinculum, and 8 we subtracted from 9. So it again become 1 vinculum. That is the procedure. We'll come to that again and again. As told earlier, vinculums with a negative phase value will repeat again, and then it reduces the effort of calculation. So while multiplication will require only 5 into 5 table will be sufficient for calculation of vinculums. These vinculum symbols are not coming properly as I told, so I just listed it. These are also didn't come properly, so we continue to use this one. So therefore, these actually, if you copy and with the normal text, say notepad, this will come properly. Whereas that these symbols we are using, it will not come to the notepad properly, as these are graphical symbols. But because there is no totally Unicode made symbols I could get, so maybe that later they will create it. Now, where the digits is more than 5, we convert it, as I told, is converted into vinculum, and we then again, after processing, we again convert back to the normal numbers. So examples are given. so that we avoid carries. See here, we have to do 8 plus 9 plus 7 plus 8. This something will be there, and the carry has to be there. Again, there's a lot of carries will be there. Whereas you just convert it into vinculum. Do you get, actually, I want some audience reaction also. Anything we
Yeah, I think
mathematical,
Well-
these things are actually require some, if you do not clarify a particular point, so far you will only discuss and there would not be any much result. But here we have started learning procedures, so then maybe have to know that whether people are understanding.
yeah, I think when you go halfway through, say next 15 minutes, after that we'll open for a bit of a 5-minute session and then again carry forward.
Right. Okay.
Right?
Okay.
Okay. Thank you.
So I do not know whether I could clarify properly or I have to repeat it, this part. Anyway, this we'll again and again learn. So let us do this example itself. See, 3, 9, 6, 7, 8. When you convert into vinculum, we did Nikhilam Navatas Charamang Dasata. This 8 is subtracted from 10 to give 2. 7 is subtracted from 9 to give 2 again. 6 is subtracted from 9 to give 3. And 9 is subtracted from 9 to give 0. And then while converting from normal number to vinculum, where the this vinculum requirement is ends, we add this to this one. 3 becomes 4 here. Similarly, here you see that everything Nikhilam, Navatas, Charma, Dasata, all these are subtracted from last one from 10 and others are from 9. And then this one is added to that, because in the background explanation is like this. This is 40,000 minus 0,332. We know that we know how to subtract, and this comes to that one. So it can verify actually. This is the meaning of this is this. So we did like this, and then sorry, actually my something is blocking here. Now, so here we see that these numbers become smaller numbers. So 2 plus minus 2, basically minus 2 or vinculum 2. 2 plus 1 plus 3 plus 2, it becomes 8. There is no carries involved here. Again, these are all add to number, these all are there. Here, there is no requirement to carry. This particular example is chosen like that. There may be some small carries at times, but not as big as this. When you convert a vinculum properly, requirement of carry will be less. When there is, of course, there are instead of 4 numbers, it can be 5, 6, 7, 8 numbers. There can be carries, but it will be less than the earlier ones. So finally, when we come to this 14 and 6468, and again we reconvert it. How to convert? Again, Nikhilam Navatas Sarmadasata. 8 is subtracted from 10 to give 2. 6 is subtracted from 9 to give 3. 4 is subtracted from 9 to give 5. 6 is subtracted from 9 to give 3. And again, when vinculum is made opposite, vinculum to make non-vinculum, it actually 14 becomes 13. It reduces. One expression is like this. This one, when you subtract, it becomes 13. Okay. This is another example. It is also done a little. When the example is chosen that way, that again we do, and here you see that there actually this full thing was totally converted into vinculum because everything was above 9. But there are maybe cases where there mixture of something is below 9 and below 5 and above 5. Here everything was above 5. So we convert it to fully to vinculum to make it vinculum less than 5. Now, here you see that there are some numbers are less than 5, some numbers are more than 5. So we convert it this way. 39 is written as 4 in vinculum 1. 274. It actually, sorry, 27. So 27 is written as 3 and vinculum 3, and 4 is left with 4. 5 is 5 actually is the optional. 5 can be converted or not converted, doesn't matter at times. When it comes falls with some other numbers, which is bigger numbers, after that we can be converted. Had there been 5, 6, we would have converted, but here it's not required. 5 and then 4 and then 3, 7 is converted into 4 with vinculum 3. 4, 9, it is 5 with vinculum 1 is called made there. And 2, so 28. 28 is 3 vinculum 2, because 30 minus 20, 30 minus 2 is 28. So here it becomes 28. This is negative. So 4 means 36, because 4 and vinculum 4. 2 is left at 2. 4 is left at 4. 38 is 4 vinculum 2. And 26 is 3 vinculum 4. With this, when you add them, see 4 and this minus 4, vinculum 4 gets cancelled. 2 minus 1 is 1 only. Minus 3 and this 3 gets cancelled. 5 minus 4 is 1. There could have been vinculum also here. It could have. I can give another example. 3 and minus 3 cancel. 4 and minus 2 is 2. And 1, this 4 and 1, 4 plus 4 is 8, minus 2 minus 1 gives 5. And then these all added to 16. So it automatically, because there is no vinculum here, suppose I could have changed the number. It could have been a vinculum here. Suppose it becomes 2 and minus 1, then it will be 19. Suppose real would have been, so 2 is vinculum 1. Real could have been, instead of writing like that, we could have written 19 in this case. So that way it can, whatever requirement is there, accordingly we do. The explanation is that it is difficult to explain actually to some extent. We actually did basically like this, as if we subtracted this 4, 3 with this one, because here we subtract, it will be lengthier. So here actually it is cross subtraction and shown, effectively it becomes like that. But here it is more clearly visible. Clear? Now, some people give some shortcuts of Vedic mathematics and only gets confined to those. Anything, any direction?
I think it's good. Good to know all this.
Pardon me?
I mean, at some point you've always used numbers, right?
No, your question is not clear. Be clear if you want to ask a question. Okay.
Any problem?
You can go ahead and we'll have a
Okay, sure.
question and answer session. 7:30.
Now, some people use, by Vedic mathematics, people have different idea. I have seen that. Some people get confined into small shortcuts and think that only that shortcut itself is a complete Vedic mathematics. It's not true. Then maybe shortcut, maybe also a part. Like some people like this idea very much. That 15 square you have to do. First you have to do divide into 2 parts. 1 and ekadikanu purbe. So 1 into 2, and then 5 square, 25. So 225. 25 square is 2 into 3. This 2, whatever number, actually preceding number, you multiply that number with the next number, means higher number. Ekadikanu purve no. So this is actually ekadikanu, means one more than that. So 2 into 3, and then simply square that last digit, means 25. You write 25. So that way it works nicely actually. So 3 into 4 plus 25 and 25, 4 into 5. So we have seen that it is 30 into 31 and 25. So these are called tricks. These are, as if people will think that Vedic mathematics is only tricks, but actually Vedic mathematics are not just tricks. These are actually not meant for tricks only. These are actually rigorous mathematics. They are having alternative procedures. These are having more, maybe on or deeper algebraic interpretation is there in every cases. So it's not just tricks. It's more than much more than tricks. So here we come to now multiplication near a base. Multiplication of the pattern, say 97 into 93, 987 into 988, those numbers can be handled in this method. A base is defined as the nearest power of 10. So like in 97 and 93, the power of the nearest power of 10 is 100. This is nearest power is 1000, this is 10,000 and so on. So we have to first identify this nearest power of 10, and then accordingly we use. So 97, then what are the shortcomings of the from the nearest power of 10? So it is 3. So we write, but with this keeping the same number of digits, we write 03 minus equal minus 03, and 93 becomes minus 07. Now what do you do simply when it is identified? We simply, right hand side, we simply multiply, like in this case 21. And here it is cross subtraction. 97 minus 7, or it will be same as 93 minus 3, is 90. So 9021 will be my answer. Okay. Now here, purposefully I keep the same number to same set of numbers to give with the idea that how it can be used. Here base is 1000, and here we have to therefore same numbers of 997 minus becomes 003. Same numbers of digits have to be kept. This has to be most important. We cannot write just minus 3 or minus 03 in this case. Minus 003, minus 007. So here, in the same fashion we do, when you multiply this 3 with 7, with keeping the same number of digits, becomes 021. And 997 minus this 7 becomes 990, or as you know, 993 minus 3, also 990. And then this will become my answer. Similarly, you can see that here also number of digits. It is seen that increasing number of nines in both multiplicants, we can keep on using more and more 9. So that will result in addition of 9 in the first part and addition of zeros in the second part. The algebraic expression is like this. So when you do n minus this, a, where n actually stands for the base minus a and base minus b. Already we identify this number is already given as n minus a, with a base minus a number. That number is identified. We are identifying here a. This is already given as n minus a. This is n minus a and this is n minus b. We are identifying here a and b. And accordingly, we are using this particular when we write already it was n minus a, and when we subtract b again from there, it becomes n minus a minus b. So this becomes my n minus a minus b, and this is the ab part. And why this shifting leftwards? This is the multiplication of n again. N is 1000 here. So when you multiply this 990 by 1000, it shifts 3 places, and then we add with AB. It is 21 here. So this must be clear. We can note down and later you ask, no problem. So here, there can be carries. Yes, I didn't, and this carry has to be added then. Then that we can discuss that example later. Simply now, the simplest cases are used. This is 124 multiplied by 13 becomes 1612. And this minus 3 becomes this one. So the result is this. Now multiplication above a base. Here the multiplication pattern is like this: 107 into 103, or 117 into 100, 1017 into 1012, 10,000, 15 into 10,000, 30, and so on. Again, the base is defined as the nearest power to obtain, and here instead of minus, earlier discussed, this is now it is plus 03, plus 07. We do the similar way, but it becomes now, we now instead of subtracting, we add 103 plus 7, or 107 plus 3, both cases, 110, and then 21. This becomes my answer. Similarly, base is 1,000, base is 10,000, base is 10,000. So this plus this is 1,010, and this 21. Keeping the same number of zeros, this also every time it to follow that. So here also this multiplied by this is 650. So this is this plus this is 10,128. Now we have seen that increasing more zeros in both multiplications results in addition of same number of zeros in the first part and same number of zeros in the second part. Here also, algebraic expression, except that minus, it will become everything is plus here. So it is already n plus A is given to you, n plus B is given to you. We only identified that it is A and B we identified, and then we added that n plus A with B, or n plus B with A, the same result, n plus A plus B. And then here in the second part we do AB, but we shift this in places. Multiply by this n to shift it towards left to adequate places, and finally we arrive at the result. Okay, multiplied by this thing, it same, multiplied by 1,000, it shifts 3 places, so that this is fitted properly, and this becomes the result, becomes correct. Now here we do multiplication near a base, but it is again mixed. Mixed is, so the one is below base, and the other one is above base. So 97 into 103, or 997 into 1012, and so on. So we repeated this sentence as actually base is nearest power of 10. Now this example is 93 will express as, we identify that A which is involved here. Basically it is the base minus 07, and this is base plus 07. So when we multiply, in this case it will be little challenging than the previous ones. So it will be minus 49. We, instead of writing minus 49, we just use the vinculum symbol. Here either I can do again n minus A plus B, or this is n plus A minus B. So minus A, sorry, n plus B and minus A, similar way. So in both cases it becomes 100 and 49. So 100, this one actually, yeah. So 100 result actually, when become 10049, when you leave the vinculum, it becomes 9951. Okay. This vinculum, we Nikhil of the Chalam and reduce this, whatever is there, to 1. So here also we do in a similar fashion. 1013, this 993. We multiply it, it becomes negative. Actually, where there is a 0, vinculum can be covered the 0, or can be above only these numbers, not covering 0. These are same notation. writing the same, it doesn't matter. Now, here it becomes either this compute this, either this 7 or 993 plus 3, both cases, it is 1006. And then this becomes, that it becomes Nikilam Navatashtara apply, and then reduce this 6 to 5. So it becomes this one. And similarly, 996 becomes 9995, and the 21 is 9979. So here also the explanation is like that. Actually, this explanation is general, whether what is positive, negative, doesn't matter. Accordingly, write the expression. N plus A minus B, this is N plus A minus B, and this becomes minus B, and we subtract it and shift it by N according to N places. According to the number of zeros, we shift. N plus A minus B. Now, there is a case where you require a sub base. So that was near a base, but it can be a some multiple or multiple of a base can be there. So, for example, we consider the base, but there numbers are given. That number those are given to us. We see that these are near to 500. Actually, this identification is required. We have to identify that we are nearing to what particular with the base, with what fraction of base or multiplication of base we have to identify. Then only I can use it properly. And here also you can do it otherwise. This base can be, you can choose either this one of these, and then sub base is 500 is called. Some multiple or multiple. Procedure will be different in cases, but obviously it will be same result. It will give same result. 483 is 17 short from 500. But keeping the same number of digits, it is like this. Same number of digits as base. So, same number of digits as the zeros in the base. Number of zeros in base is this 3. So you keep the 3 digits, minus 017. 497 is minus 003, actually, right? 500 minus this 003, so we write this way. And then again, here, like earlier we did, 483 minus 3, it becomes 480. 497 minus 17 becomes also 480. We write that way. And then 17 into 3 multiply 057. But finally, we have to take care of this base. When we use the sub base, we again divide it by 2. And here, in case we use multiple of the base, we use a sub base which is multiplication of the base. We have to write that, we have to multiply it. So here 483, we here in the base you have two zeros. So we write, preserve only 2 digits in this. It is directly minus 17. It is 500 minus 17 is 483. So we write minus 17. Here we write minus 03. Same number of digits, 497 is. And we simply multiplied it 17 into 3 here. Here actually this minus this is 480. When we multiply it by 5, it becomes 2400 and 51. So you see that either you write 240 and 051 or 2400 and 51. The result is same. One more example is there, above a sub base. So here also you see that it is above a sub base. We did the same thing. Here we do 51 and 517 plus 3, 520. We divide it by 2 to get 260. Here also 517 is 17 above 500. So number of digits required is 2 only. 503 is 3 above. So we multiply by again 51. So 5 when you multiply, it becomes 2600. Either 0 comes here or it comes here. So it result is same. Now, there are some cases we will find that little challenging. So I discussed that cases which are not carrying and so on, but it can be there can be carries in this case. So here one is above zero, above this subbase, or one is below subbase. So here 483 is below subbase, so we write minus 017. 507 is 500 plus 007, we multiply, but is this time plus into minus, so it will be vinculum, or it means negative. Plus into minus is minus. Now 483 plus 7, this 7, 490, and this or this also is 490, obviously. And then we divide it by 2 to get 245, and this is 119. And this 245, 119, when it comes like this, it becomes 244, 881. Nikhilam Navatas Charmadasata, and reduce it by 1. But here, since the 7 to 7 doesn't fit 2, we write in the left with a little carry, we preserve this way. And this we finally add to this one. This also becomes negative. This carry is also negative. So basically it's 119. But here, this is, 2450119 negative, not negative. This is 245, and then this vinculum 1 gets added to this 0 to keep negative 1 again. So this finally become of this form only, and the result is same. Now here we again give some more examples. 235 into 247 becomes 1000. Base is 1000, but whereas subbase is 250. This we have seen that is 250. Is 1/4 of the subbase. 1/4 of the base. Subbase is 1/4 of the base. So 235 is 15 short of 250. 247 is 3 short of this. So similarly we multiplied, and finally we this result was 235 minus 3, 232. We divided it to get 58, and 58045 is my result.
Gautamji, can we have a 5-minute interaction before we move forward?
Yeah, sure.
Okay, Babu Garu, are you there?
Yeah, there are some 1 or 2 questions.
So we'll ask them to talk, unmute.
All are unmuted.
Right. So sequentially, you raise your hand so that we can take one by one. So you can raise your hand digitally so that we can open you.
Please.
Yeah. There is only one question in the chat box. Okay, Hemlata, yeah. You can go ahead.
Sir, namaste,
Okay.
sir. Namaste, Gautam, sir.
Namaskar.
Sir, it has been very interesting. I just wanted to know, like in all examples, you have taken the same base, like you took 235 into 247, this last slide. 235 into 2000 something, if I want to take. One is in hundreds, one is in thousands.
You have
Then
to
can you
use the same base. It will be very big in that case. There are ways, of course. There are ways. As you pose the question, I will get those kinds of examples. There are actually ways for that.
Okay.
Let me put it, we are right now trying to do simple things, understand simple ones, then we go to complicated ones. So right now in basic course, it's only simple
There are ways, like
Vedic mathematics.
right, you write the same numbers, or fill up with similar numbers of 9 and so on. There are so many other procedures are there. But as procedures, Background, we can always, conventional mathematics we can do, but there will be procedure for that also. When these are not equal, what to do. When this is more, that is more, what to do that. There's so many procedures.
Okay, sir. So I just wanted to know its method is
No
available.
problem.
Right now, we are
Actually,
not
this
learning
is very good actually. When you want to know more, so that we know that the comprehensive nature you understand, no? You get that.
it.
It can be easily. For here itself, there is a little example which is a little challenging. No, we should not say complicated, but it is a different actually. So 18 into 45. So here it becomes very big. 50 is the sub base, where it becomes minus 32 and becomes
Pantulu garu
minus 5.
wants to ask a question.
Acha, please.
Hello, sir.
Yeah,
Good morning, sir.
Good morning.
Namaskar, Dodi.
Namaskar.
A very interesting class. Very happy to have this type of sessions.
Yeah, thank you.
Regarding this applications of mathematics in general life, I would like to have small doubts and question.
Okay.
All right. Generally, this as per mathematical principles, minus into minus is plus.
Yeah.
Okay, sir. That minus is indication of debt generally.
Yeah.
Minus is indication of debt. If a person is having debt, his net liability will be in minus. Hello.
Okay,
sir.
go
Yeah.
ahead. Complete your question.
Yes, sir. If
Please go
suppose
ahead,
the
yes.
same person has borrowed and he will be further in debts only, his liability will be increased. But how it is plus in this example?
No, when we add those dates, something is negative number is added with negative number, it becomes further negative number. You are telling that. But
Yes, sir.
dates multiplied by another negative dates, what does it mean? Obviously, it will be opposite now. We are doing negative of negative, ulta. Something with this mobile, actually, we hold this way. We make it reverse. Okay. We make it further reverse. So this will be straight again. So that is my negative of negative is positive. That it means right. So therefore, the negative multiplied by negative means negative of negative, which becomes positive.
But in the practicality, if a person having debts, if we take more debts, his liability will be in debts only, minus only.
This you are thinking in terms of addition of debts. Okay, multiplication of debts. How can you give an example of multiplication of debts? Actually,
suppose he takes 5 times of his debts, 1 into multiplication, nothing but additions.
No, but how you can take minus 5 times of debts? It's not possible in this particular practical example. Normally, these negative numbers we map it with debts because to make people understand what is positive and negative and so on. But when you multiply this thing, multiply, we know that double, triple we tell, but never you told that minus double, minus triple. These kind of things are not common, no? So this only is possible in mathematics. There can be some, maybe that since you are thinking in line, maybe one day you will be coming out of that, how in terms of debt, multiplication of debts, another debts multiplied by another debt is possible.
So multiplication also nothing but additions, na?
I'll think that how it can be example can be money
Right.
mapping the example of debts can be we can handle minus into minus is plus. How can
Yeah,
be explained?
if you can come back to explaining the slide you were explaining, sir, please.
Right.
Okay.
Thank you, sir.
Okay. Thank you. Now I come back to this one. Later on we can.
Right. Okay. Thank you. Thank you,
No.
sir.
Now 18 into 45. 18 is minus 32 and 45 is minus 0.5. Now when you multiply these things, it becomes 160. Okay. But here there are two places to hold it. So this becomes 60. We write and we carry as 1. So that actually these are here, whatever you wrote, it goes straight away. I mean, there is no carry. This carry means actually we cannot write along with this, but it will not become 5 digits. It will actually have to carry means you have to merge it, I mean, add it with this previous one, add or subtract as the case may be. Now this became actually 13. So again, but this is odd number. When you divide by 2, it becomes 6.5 and 160. Now this is, see, you have to think it properly. So 6 is 6 we write, but this 50, this half in this it actually digit is 100 digit. This one actually contribute 50. Contribute 5 in tens position means actually it will be 50. So this 50 we write, and this again, this 160, it becomes 210. So you can write it this way also, or you can straight away. This 2 is a carry, so you add with this. This 2 is added to 6, so it becomes 8, and then 10. This 810 becomes my result.
Sir, please repeat it, sir.
Okay. So here, see, 18 is minus, this part you understood. Now this 18 minus 5 is 13, or 45 minus 32 is 13. And this 32 into this 5 is 160. But there is only 2 placeholders. So 60 we write, and 1 we write in the carry format. It is a little left and little small, we write. This is meant for adding with this. Had there been only, suppose, we would not have multiplied, divided by 2. So it is 13 and then this 16. We would have written straight away 1460 would have been my answer. Had there been no, suppose it is not a sub-base case, it is a base case, and we got this kind of numbers. So you could have 1460 straight away. But here we are dividing by 2, becomes 6.5, not an integer again. Suppose had it been 7, for example, in this case, 7 and 1, this carry 1 and 60 would have written 860. But it's not. It is actually 6.5. This half actually in the third digit from right means that in the hundreds place, this becomes 50. This 50, and when we add this 160, this becomes 210. We can, instead of writing this is not required again, 210, we could have added with 6. It means that 600 plus 210, so 810. We could have thought that way also. But if we want to write this again in this format, we can write also. But this writing this 2 and 10 is not required. It is straight away, this is 50 plus this 160 becomes 210, and added with 600 becomes 810.
So,
Or
sir,
what we could have done, like this, it is actually 650. This is 650, basically. Or not, even you may not write this way. 650 plus 650 plus 160. So 650 plus 160 becomes 810. That also you can think. Clear?
sir, suppose it was 13 divided by 4 or something, and we got 6/1/4, let's say, for example. So if it was 6/1/4, we would have written 25 plus 160.
Right, 25.
Okay. Thank you, sir.
Now, explanation of this is like this way, algebra. Algebra of the sub-base method. Mn minus a into mn minus b is mn into mn minus a minus b plus b. This a actually, again, this thing is mn, this is mn minus a minus b will be evaluated by your, this part before division, and this will be ab part, right one. But n will be the number of digits shifted, that is, up to this is fine. similar to previous one almost. But this multiplier 5 m is in this case it is 1/4. So this have to be, it's a division of 4 is explained by this one, this m. Here in this case here here m is 5. Here m is half. M is 5. So after shifting the digits, we clear example I do here. So we did after shifted the digit, but here we wrote this. This is the AB part. Here we shifted it by n. Means these two zeros we shifted, but again we multiplied by m. So we get this. So this is the example. This finally everything after shifting, we shifting by this n, we multiply by m. Now, so if there are more questions, later we can come back in this particular method. Now I come to another method. It is called
Gautamji, we are 5 minutes to 8.
Huh.
So should we start the new method today or tomorrow? And take a few questions?
We will start the new.
Because it's
tomorrow.
only 5 minutes.
We'll have it tomorrow only, but today we will complete question answers and then close.
Okay.
So could you go back 2 slides?
No, but question may come that, sir, you are using particular examples. Suppose there are completely different kind of thing what you do. So I just at least one slide I do. There can be this method.
Okay.
At least there people should know that there are other methods tomorrow to be covered. In the Urdu Tijaga, you do not go by anything about the base. The base method is not the base method. So it is like this. Two numbers can be like 10a plus b and 10c by d. What you do, you group into. We also do by conventional mathematics in a different format. Here we group into the power of 10. So BD and AD plus BC the 10's power and AC becomes 100's power. So what do we do like this in a procedure? We write most digit, we simply do by 3 into 5 by this 5 and write 1 as a carry below left. Here we do 4 into 5 plus 3 into 2, which becomes 26, and write 6 here, 2 in the left below, and 4 into 2 becomes 8. So finally we add and this one. And we do normally, we multiply everything by 5 in the first row and then shift towards left and multiply everything by 2. This way conventional mathematics we do. Here actually it is different. We write in this format, means that and the 3 digits. We group into here it becomes more and more becomes complicated. We group into unit, group into tens digit, 100 digits, 1,000 digits, and 10,000 digits in this case. And accordingly, we do 4 into 2 is here 8. 1 into 2 plus 4 into 5 becomes 22. You write like this. 3 into 2 plus 4 into 3 plus 1 into 5 becomes 32. 23. This one, right? This way we do. We group into number power of 10 and then finally add. Okay. Anyway. Now we can open for questions from today's session.
Yeah, now it's open for questions.
Any previous slide I go? Normally people ask question on this.
So questions, now people can ask questions. We are keeping it open.
Here or in multiplication?
I think there are no questions. Bhattacharya ji has a question here.
Namaskar ji.
Namaskar, Gautham sir.
Namaskar.
My question is that already we have measured whatever learned in the normal practice what we are doing in mathematics.
Right.
But now apparently it is showing that it is being complicated, and how to not only that, if anybody solve any problem in this method, the teacher or anybody else who is not aware of this method, he may not understand whether it is right or wrong. So what is the bridge between to know the procedure or say the procedure as per our method which we have already learned? Because Vedic mathematics is definitely earlier than our normal mathematics which we are doing.
Yeah. No, but see, the conventional method is one of the methods used. I'm not telling that it is a completely out of the way. You have to use always something different. See, out of the so many procedures, our conventional method picked up only one. That is what I want to say, and that is my objection. That whatever be, suppose this could have been a easier way. In conventional method, is one of the method. I'm not telling that this is non-Vedic or something like that. That maybe there are Vedic methods used in all other ways. So this is also one of the methods. You just you 8 plus 9 plus 7 plus 8 you do and make a heavy carry, and then you will it. Nobody is objecting to that, but he's not telling that is something.
How
But
can we match our understanding with this method? Because I personally feeling some different, but appearing that we are considering base. In case of 3 digit, we are taking base as 1000 divided by 2. In case of 2 digit, we are taking base as 100 divided by 2. How it is how these things we are doing under normal conventional method, we do not do in that, because we have already habituated with that practice.
that's what I'm telling. That learning with the this to change your mindset, to change it, so that it become more flexible in terms of mathematics. We do not become rigid of learning only one, since we learned it from school that this must be the only one method, only method. All others are looking at tricks. No, we could have started our career had that been possible. We could have started our learning this way. That okay, with learning all different alternative methods.
Okay, thank you.
In fact, there are so many trials in being carrying on, so that these kind of things will be introduced in 5, 6, 7, and so on when you start learning mathematics. These are not very higher. These are not very higher, like integration, differentiation, all those concepts. These are meant for schools basically, and some people do a number theory. They are doing it in number theory in the chapter they are learning, but actually they are very easy, and it is meant for consumption in school itself. Say any child can understand this thing and can master this one. Simply do they need not see in 5, 6, 7 they need not even learn the algebra, but they learn the procedure first. The 9 and 7 you have to do subtract it, and then you multiply this one. Like simply this is answer. Otherwise, see, you do 3 into 7 and 3 into 9, 3 into 9, write this way, 9 into this. Big, you do all this calculation, heavy carry, and so on. This one, it is so short, so transparent. You can see it exactly. This is the when your eyes get set, you see that this is the correct. Still, if you doubt, you can always verify either by conventional method or calculator or whatever it is. But here you see that it is more transparent. When your eyes get set, you write, yes, I have done it correctly. When you get, how do you match with another one? Either we rely on that particular method. Here, when you rely on that particular method, you understand this must be correct. Yeah. Any other question?
Yeah, Ravindra Pantru garu.
Sir, again one more, sir. Sir, is there any difference between abacus mathematics system and this Vedic mathematics?
Abacus is there. Abacus is actually there are different. They are still different. This is we were talking of.
Anyway,
We were talking of this one, no? This
Yes,
is
abacus.
abacus.
Yes, abacus system.
And here the procedure that you will just this 2 you do, it becomes represents 5. You lift the number of these things. These will be there when it is stop. Actually, this is 0. Okay,
Yes.
and this one towards left becomes 5. And suppose this is 0, this is 1, this becomes 2, this becomes 3, this becomes 4. When you have to do 5, 5 will do this one. The left one you shift towards this one, towards there's a line. Again 5, this is becomes when this 5, this 5, this becomes 6, this becomes 7,
Can I
this becomes 8,
intervene,
this becomes 9.
Gautam
And then
ji?
you, after shifting this thing, becomes expert and these things. But I don't think there is a similarity. These are completely different, and we do not need any instrument or anything. So this is okay. So abacus is also one method, but not the. We cannot say it is similar to abacus.
Okay, I think we should have the questions relevant to the present class. Always have this thing in mind. See, we are running into the basic,
No, still,
very,
for
very,
general,
very fundamental nature. Many others may not be so comfortable, so they may be feeling, one person said, I'm not understanding anything. Naturally, there are people. So let us have a question on the present class and go step by step. Don't go outside the class. Let us understand this class.
who told that didn't get anything?
there could be questions, So
Okay.
yeah.
No,
Okay,
anyway,
Babu
my
garu.
number is given. My number.
Babu
Even
garu,
outside
okay.
class, anybody can ask me questions.
Right, Vijay Kambhate.
Thank you so much. First, Shubha Deepavali to everyone. Sir, thank you so much for the wonderful session. Sir, I have two generic questions. One, this Vedic maths, can we use it in a number crunching in programming language? Number one, that is first. And second, I read somewhere that even NASA uses Vedic maths. I'm not sure whether it's a true or it's a false claim. So if you could just throw light on this, it would be great. Thank you so much.
Actually, in connection with the tomorrow's class,
Okay.
There is a research. They actually instead of using conventional method of multiplication, what you do, you multiply everything by unit digits first, and then again by tens digits, then third, and we shift it properly. If we group into this kind of things in the powers of 10 method, so number of steps involved is less here. And so in every step in the multiplication, we reduce the effort, and it is some nanosecond is reduced. And not only that, power is reduced here, power requirement. So imagine if there are billions of devices in the all throughout world, and each device, even to display mouse, see that mouse, even to move a mouse, there are thousands of calculations being done in the background. Even to display, suppose this dot is displayed here, this one is displayed here, in which particular position it is displayed. There are a lot of background calculation in the screen. Millions of calculation, millions of multiplication are always happening in the background, in your mobile, in your computer. So somebody estimated that there could be megawatts of power saved if Vedic mathematics is used in the circuitry.
Okay.
You understand? There is a research paper on this.
Oh, okay.
So it is people should not say that Vedic mathematics is just for academic purpose. It's not.
Okay. Thank you so much, sir.
Yeah, thank
Okay.
you.
Now, with your permission, Gautam ji, we will close.
Okay. Still, some actually, can we insist people? There's a PPT shared. Can you insist you to make your own example and try to solve it? And if any problem comes, we can discuss it. It will be good.
That is the homework. Please take your own examples and then solve by this method. And tomorrow, if any problems, then we will discuss.
Okay. Yeah.
Right.
Okay. Now let us go for Prarthana. Venkateswar garu.
Stop sharing.
Thank you so much.
Welcome.
स्वस्ति प्रजाभ्यः परिपालयन्तां न्यायेन मार्गेण महीषाः गोब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथिवी सस्यशालिनी देशोऽयं क्षोभरहितो ब्राह्मणाः सन्तु निर्भयाः अपुत्राः पुत्रिणः सन्तु पौत्रिणः अधनाः सदनाः सन्तु जीवन्तु शरदां शतम् सत्यं वद धर्मं चर स्वाध्यायान्मा प्रमथ मातृदेवो भव पितृदेवो भव आचार्यदेवो भव अतिथि देवो भव सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ शान्ति शान्ति शान्तिः ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्ति शान्ति शान्तिः सर्वे जनाः सुखिनो भवन्तु स्वस्ति हरिः ॐ श्री गुरुभ्यो नमः हरिः ॐ
ధన్యవాదములండి. అతి ఉత్తమ. Now let us request Challa Chittibabu garu to recite national anthem, please.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद
Jai Hind.
जय Okay, I think we can close now.
ధన్యవాదములండి చల్లా చిట్టిబాబు గారు.